IFMIF means International Fusion Materials Irradiation Facility. And its objective is the irradiation of structural material candidates for DEMO. DEMO is the next fusion research reactor after ITER, which is besides just having high tritium deuterium fusion plasma. Also, it's going to have a breeding blanket system where the tritium is bred for the fusion reactor, and at the same time where also the energy of the neutrons is going to be turned into heat. So in this DEMO, structural material is going to be used. Yes, and the problem is that compared to ITER, where you only have more or less one displacement per atom in the structural materials of ITER due to its rather low neutronic load on the first wall. You can see it here, it's more or less 0.07 megawatts years per square meter. In a real reactor, and almost also the same applies to DEMO, maybe a little bit less, you have 10 to 15 megawatts per year per square meter, and you have displacements per atom of 100 to 150 per year. You see that in a real reactor compared to ITER, for the materials, there are way different requirements. And to study which, because of the high neutron flux and radiation, and to study these materials, until now you don't have any device. You don't have any device which can produce a neutron ray, which is comparable to the neutron radiation in a real fusion reactor. So to test materials which are exposed to such a neutron radiation, now this International Fusion Materials Irradiation Facility is going to be built and still under design, and is going to be probably constructed in the next 10 years. However, before IFMIF, an early IFMIF is going to be constructed, which is called DONUT. IFMIF, the setup of IFMIF looks like this. We have two accelerators which accelerate deuterium ions onto a lithium target. The lithium target is liquid lithium, and the liquid lithium is flowing in a liquid lithium loop with a quite high velocity. The energy of the deuterium is more or less 40 mega electron volts, and due to nuclear reactions between the deuterium ions and the liquid lithium, that we have a neutron ray produced, which is produced behind the lithium target, which is comparable of its energy with the neutrons in a fusion reactor. And this neutron ray can then be directed on material samples. Whereas DONUS, the early IFMIF, will look principally the same, except that we only have one accelerator and therefore also just 20 mega electron volts. However, to expand it to IFMIF, you just need to add another accelerator.